Hello, my name is Trevor Howitt, and welcome to the product demo 1 of my Capstone project, Base Paths. This presentation will be split into 3 different sections. The first section will cover our application context, requirements, and architecture. The second section will cover a demo of the application and where it stands thus far, as well as the tests for for the application. And the third section will be a reflection on the project thus far. Jumping into section 1, starting with what is Base Paths? Base Paths is an integrated system for generating and managing road trips based off of the Major League Baseball schedule. I'm personally a big baseball fan who likes to take road trips to see games every other year or so. Um, Lining up these trips can be difficult. Maximizing the amount of games to see on these trips is a difficult thing to do. So jumping into our application context and ConOps off of that point, why is this system needed? Well, planning these trips to see Major League Baseball games is difficult and can be inefficient. Each team hosts 81 games a year, and figuring out which teams are at home and which teams are on the road can be a challenge. I personally, this summer, just took a trip from Kansas City to Boston, where I drove all the way, and I saw 4 games. That is hardly maximizing the trip. There are a lot of teams in between that I was not able to see, simply because the schedule is hard to follow. This tool will help users maximize the number of games that they wish to see on a given route. The system is meant to be used as a tool to assist with planning road trips. It's going to give you a list of games that are possible given a number of inputs that you put in, like start location, end location, duration, so start date and end date, as well as maybe some stuff about maximum travel time per day and other inputs. It's not necessarily going to give you routes through road systems or anything like that, but it is meant to be a tool to assist in road trip planning. How will the system be used? Well, on a local system, a user will be able to access their application via the web browser. So it is a locally running application, as we will get into in the architecture in a bit. It runs in Docker locally, and then they'll access it via the web browser. Users will be able to create different accounts to track trips for different people if there are multiple users on the same system. They will also be able to create trips based off of start and end locations and dates, and as I mentioned, generate the maximum number of games that they can see in that trip. And then the system will also, as mentioned, run locally in Docker, and it will not require a connection to the internet. The only connection to the internet needed will be to clone the repository and deploy the system in case there are any packages that need to be downloaded. Who will benefit from the system? It's a little niche of a group, but it exists nonetheless. That's baseball fans looking to maximize a vacation. These are baseball fans like myself. I have encountered many others on my trips as well who are looking to get the most out of their vacation. I have a goal to visit all 30 Major League Baseball stadiums. I think 12 through so far, so long ways to go, but I am certainly not the only one that I've come across with this goal. So next section, we're going to cover our software requirements. So our backlog splits 13 functional requirements into 11 different user stories. We can see those functional requirements here in our SRS document. So the functional requirements that we're focused on for this section, so Sprint 1 and Sprint 2, are the functional requirement 1 to create an account with a username and password, functional requirement 2 to allow login and logout securely, functional requirement 10 to load ballpark and schedule data when the system is deployed, and functional requirement 13 that the system will be using a deployment script to run on the local machine of the user. And then if we want to look at the backlog as well, we can see our 10 different user stories, sorry, 11 different user stories that are in here. They're in various states of done and ready and backlog. There are additional user stories that you'll see here, like Sprint 2 documentation task that was used to help organize some documentation work that needed to be done prior to this demo, as well as I believe there is a Oh no, it's not. It's not. It must not be a user story. There is a tech debt, the parent task somewhere to handle any technical development that needs to be done that doesn't fit in a clear user story. So we can cover our summary of work between sprints. I'll pull that back here. We can see that sprint one included user stories 1 and 2, so that was create account and the login log out. It also handled a lot of project setup, creating the back end and the front end and database stand up. A lot of that overhead was completed in Sprint 1, as well as investigations into specific implementation technologies that wanted to be used for different user stories. Some that were worked right away, some that were planned later but needed to be set up uh, so that we didn't conflict with the desired implementation in earlier tasks. Sprint 2 covered documentation catch-up, which we will dive into a little bit later when we do the project review on why that was necessary, as well as user stories 10 and 11. User stories 10 and 11 covered functional requirements 10 and 13 about deploying the system and loading ballpark and schedule data. So we can look at these user stories here. The loading ballpark and schedule data specific one has to do with that data needs to be loaded into the system upon deployment. Otherwise, we won't be able to plan trips without having ballpark locations or game schedules. And then our deploying the system was integral to get done early to ensure that we could get this stood up, and it didn't. It was good to have stood up early so that we could test on a system that mirrored how it will actually be deployed. All right. The process for generating which tasks we work each sprint has evolved greatly as different patterns are discovered, particularly testing cycles and overcoming some technical challenges has given a lot of insight into some helpful ways to plan for that. This is my first time running a project like this. I work in Agile a lot, and I've actually done Scrum Master work. Um, but I have a whole team of people typically that have a lot more experience than me to help me out when I have been in those roles. This is my first time handling it on my own, and I've certainly walked into some pitfalls here or there. Um, so we're talking about like testing cycles here. That's learning. I think the first sprint, I wrote a lot of systems and unit tests before writing user acceptance tests, and learned pretty quickly that wasn't going to work. It was going to be way more efficient if I did user acceptance tests first and then unit and systems tests. And so that helps plan for the work to be done in the future. All right. Sorry if there was a jump, maybe some technical difficulties there, but as I was saying, uh, the testing cycles helps plan for what tests to write um, at the beginning of sprints, at the end of sprints, how to set that up. Additionally, overcoming technical challenges, learning. It's sometimes hard to predict where you're going to find pitfalls. I've written bash scripts before. I thought that was going to be a relatively easy thing. It ended up being a little bit more difficult to sprint and took up some more time than was necessarily expected. Luckily, I haven't had anything roll quite yet, so my estimations are somewhat in line. Although I do wish this sprint I was actually hoping to pull in a little bit of work. I left some buffer there, particularly for documentation work. But unfortunately, the deployment script chewed up a lot of that buffer pretty quickly. Next, looking at our software architecture, we can look at we have 5 non-functional requirements that really drive our architecture. We can look at them here in our SRS. They center around, as we can see here, 5 major points of quality attributes: portability, reliability, security, and usability. Sorry, four different quality attributes. So we can see them laid out here. NFR1 is about deploying across different environments without modification. That's our portability. Um, NFR2 is about securely storing user information. That's our security. NFR3 is about maintaining automated tests at a certain coverage percentage, and then automating those tests. That helps our reliability to ensure that there are no breaking issues in the code. And then NFR4 and NFR5 are related to usability, providing a consistent layout across pages, which we will see in a couple slides with some UI wireframes, and then the system displaying clear error messages when operations fail, which we will also see in those wireframes. So the architecture is shaped by these NFRs. There are a number of technologies used in building the application. Docker is used that really increases our portability. Um, and then Spring Security being used for reliability, um, which we'll get into on our back end. I have an architecture diagram that will dive into all the technologies next. Using a React UI for our front end helps increase that usability, that consistency across pages, ensuring that things look the same. And then our automated testing really helps with that reliability using GitHub Actions. Any changes made to the architecture? To be honest, there haven't been a lot. I feel like my architecture, I have a lot of confidence in my architecture, and it's fairly robust. There have been some small changes. Spring Security was planned from the beginning, but not something I had used a lot. I wasn't entirely sure what kind of authentication we were going to use with that, or at least I was going to use with that. So using a JWT token to authenticate was added after some investigation to different security practices that was deemed the most appropriate for this project, mainly due to, frankly, its simplicity. I didn't want to spend too much time creating an elaborate security uh, scheme here, especially since this is a application that's going to be deployed locally on one system. Users are likely going to be knowing each other using the same personal computer or whatnot. So yeah, and then the other one is using a bash script for deployment. I wasn't sure exactly what kind of deployment script I was going to use. I was somewhat hoping to build it all in Docker Compose, but I had to wanted to use the load data and also do some additional checks beyond just the Docker Compose. And so ended up using a bash script because that ports pretty well to different environments, obviously running on Linux and Unix systems as is, and then a quick uh, Git bash or Windows subsystem for Linux to run those on Windows. So next, looking at our architecture diagram here, so we can see that we have our front end, back end, and database containers all running here in Docker. That's our portability right there, as well as our bash terminal that runs our deployment script. And then we have Spring Security with our backend controller that helps with our security our security attribute, and then our test automation with GitHub Actions helps with reliability. And then moving to the next one to talk a little bit about usability, we can see UI consistency. These are our UI wireframes. We'll see it when we demo all of our tests in the next section, but these are pretty emblematic of how the application looks. We can see our login page and our create account page are extremely similar. They share the same kind of general scheme, and we can see these error messages here are clear, concise, and consistent across pages. So that's it for section 1. We will then move on to section 2. Okay. Now we can dive into section 2, where we will cover application features and testing. So starting with our application features, as mentioned earlier, I've developed 4 user stories here in these 2 sprints. User story 1 and 2 were done in sprint 1, and user stories 10 and 11 in sprint 2. So these have to do with account registration, login and logout, loading the system seed data. So that's going to be MLB ballparks and the 2026 schedule, and deploying the system. So the question being, why not more user stories? I certainly think would have liked to get a few more in there, but here we are. No, that's it. So the biggest ones, user stories have been a little bit bigger than initially considered, a little bit more overhead and investigation required. Working with new tools is always tough. It can be difficult to predict exactly what kind of issues you may run into. We'll dive into that a little bit later in this presentation, as well as external circumstances. Again, we'll dive into that a little later, but I've been asked to work overtime at work, which has put a damper on some of the time that I was hoping to have to work on this presentation. But obviously, life goes on. Still need to get this done. So next, we can look at our testing report. So to start with this, I figured I'd do a walkthrough of all of the user acceptance tests. This will give us a good overall demo of the current state of the application. So with that being said, we can go ahead and look in our software testing report at our user application tests. So you'll notice I'm starting with user acceptance test 8. This is because this is the initial deployment one. So I can go ahead and pull up Docker here, and I can see, let me actually clear these. These are just leftover images, but if I clear these, then we will be completely clean slate. Now that those are gone, we can see that there are no images, no containers on the system. And so we can start from scratch here. So looking at our software testing report here, we can dive into the acceptance criteria of this first user acceptance test. So given the user is on a system with Docker installed and the application is not currently installed, which is true, and the repository has been cloned, that is also true. When the user runs the deployment script, then the script completes with no errors and the system is accessible. So this is going to be run from a bash script, so we will go ahead and jump over to bash. So here in bash, I am located in my repository here. I've gone ahead and navigated there. If we look at the user acceptance test, that is the first step of the test execution steps. So in the command line, enter the root directory of the base path repository. Next, we're going to run the deployment script. So that's going to be deploy .sh, and we will go ahead and run that. And we can see that we get some start notifications and then some stuff about loading a key and removing old containers. So while that loads, quick explanation here. We're actually going to be observing the results of two different user acceptance tests with this one singular run of the script. Actually, I take that back, three different user acceptance tests. So user acceptance test 8 focuses on successful initial deployment of the system, and then user acceptance test 12 and 13 have to do with loading our seed data. That seed data is loaded as part of this script as well, so we can observe the outcome of these at the same time. So we can see the steps here. Given the user is on a system, the application is deployed and running, and the ballpark table in the database is empty, which it is. Because Postgres was not even installed yet. The ballpark data is present and valid, which it is. It's in the repository. Then when a user runs the deploy script, then the ballpark data is loaded in the database. So what we should expect to see is that when this runs, we'll get a message stating how many ballparks were loaded into the database. Similarly with game data, exactly the same, just a different table in the database. But same acceptance criteria there, but with game data instead of ballpark data. So we should be able to observe that alongside the successful initial deployment, which we can check on right now. Looks like the script is completed. So we can see that we get confirmation that the backend is running, the front end is running, and the database is healthy. We have this message for loading ballpark data, and we see that 30 new entries were added, and then loading the schedule data, and we see that 2,431 new entries were added. That is the expected number, and we get our deployment successful message. So now the next steps here are to test the containers. So we've got to run Docker PS. That will tell us that the containers have been up about a minute. And then our next step here is to, in Chrome, navigate to localhost 5173. So if I hover over this bookmark, we can see that's localhost 5173. We get our login page here that confirms login page should show. That's expected. And then we can navigate to localhost 8080 Swagger UI index HTML. That will load our Swagger page for our backend. You can see the URL there. Go ahead and click that, and we've loaded Swagger. Next, we can open the ping endpoint in the user controller. So in our user controller, we have an endpoint called ping. The next step is going to be to hit try it out. and then hit execute, and we get a 200 with Pong back. That confirms that it is up and running. So that is good news. That means that UAT8 is successful. Moving to UAT 9 here, this is running the deploy script when the application is already deployed. So we have a deployed application now. We can see it here in Docker. It is deployed and running. And so this user acceptance test calls for us to run that script again. What it should do is redeploy the application without any data loss. So this should just take the containers down, rebuild the front end and the back end, and redeploy them. So that is the general idea of what it's doing. What the actual acceptance criteria is that given the user's on a system with the application already deployed, when the user runs the deployment script, then the script completes with no errors and redeploys on the system. So we have our steps here. These are identical to the steps in the first user story that we covered, or the first user acceptance test that we covered. So let's go ahead and run that script again, and I will cut to when it is complete. Okay, we have a successful deploy here, and what we can see is we can jump back to that user acceptance test now that the script is complete. We want to run a Docker PS again, so we can do that, and we will see that the status is up about 30 seconds, which is to be expected given that we just reran it. We can jump over to the the next thing that we need to do is check the front end. So we can check that. We get the login page. Then we'll check the back end. Swagger page loads. Our ping endpoint executes to a 200, and we are good to go for user story or for user acceptance test 9. Now, something interesting, we also have a corresponding data load user acceptance test that we can observe the results of at this point. This is data loading duplicate data. So I mentioned that none of our data was erased when we did the redeploy. So given that the user is on a system and the application is deployed and running, ballpark and schedule data is present and valid, which it was from the initial deployment. The ballpark and game table in the database are populated when the user runs the script. Then the script passes and no data is added to the database. So we should see that in our run here, we get 0 new entries were added to the ballpark data and 0 new entries were added to the game data, which is exactly what we expect to see. So we see that user acceptance test 14 is also passing. So those are our 3 user acceptance tests for our data load. So those are all passing. Now jumping back, we have covered user acceptance test 8 and 9. We can cover user acceptance test 10, which is attempting to stop the running application. So in this one, we have a running application, which is the current case as well. If we look at our Docker, we can go ahead and come over here. So given that the user is on a system with the application deployed and running, when the user runs Docker Compose down, then the application stops with no errors. Application is deployed and running on the system is our precondition, which it is. Next, we can look at our test steps here. So in the command line, enter the root directory. That's where we are. And we can run a Docker Compose down, and that should execute with no errors. So we can come here, and Docker Compose down. That should execute with no errors here. And then we can check what our next step is. It's to run Docker PS, and we see no containers, which is to be expected. So this test passes. Next, our acceptance criteria for user acceptance test 11, which is involving restarting that system. So given that the user is on a system with the application deployed and stopped, which is our current state, given the user runs Docker Compose up, then the application starts with no errors. So we're going to run Docker Compose up specifically with the -D so that it doesn't lock up our git bash here. Those -D, and that should create all of our containers there. We can run a Docker PS and see that our containers have been up for only 10 seconds. And then we can do our regular walkthrough here to check that everything is running. We can check the front end. We can check the back end, and we can hit the endpoint here. Execute that, and we get a 200 back. So that covers user acceptance test 11. So that covers all of our user acceptance tests for the tasks worked this sprint. So our deploy script and our user acceptance tests. We'll circle back and cover the first sprint's worth of work, which is going to actually involve using the system itself, using the front end. So this first one involves creating a valid user. So this is going to involve, so given the user is on the create account page, when the user enters a valid username and password and clicks create, then the user is redirected to the home page. So our first step here is to actually navigate to the create account page. So we can come here and create account. We can also hit the sign up button that you see there on the page, but I'm going to just go directly there. And then in our username field, we can enter valid user. And in our password field, we can enter valid pass. And then when we hit create, we should be directed to the home page like that. And so that is passing as it fits our acceptance criteria. The next one is attempting to create a user with an invalid password. So I'm going to go ahead and log out and navigate back there. So valid user is what we're going to use here. This is given that the user is on the create account page. When the user enters a valid username and an invalid password and clicks create, they should get an error message on the login page. Sorry, on the this should be the create account page on the create account page. I think that's just a small copy paste error. If we go invalid pass here, if we copy that and we paste that in here, when we hit execute, we get an error for an invalid password. So that's going to pass. We get our error on, and we remain on the create account page. Our acceptance criteria for user acceptance test 3, which involves creating a invalid username, a user with an invalid username. Very similar to the above ones. I'll rush through this a bit because I want to make sure that we have time to look at other test types. But we're going to look at the username just being you, and we want to make this valid pass 1 exclamation point. If we execute that, this is an invalid username, and so we get a message for the username parameters. Next, we want to create a user with a duplicate username. So if we attempt to create that same user that we created the first time, we get a username already exists error. Our next user acceptance tests have to do with login, logout. So I'm going to navigate back to the login page. We're going to go to login. And we're going to follow the steps for this first one. So the acceptance criteria for user acceptance test 5 is that given the user is on the login page, when the user enters a valid username and password and clicks login, then they should be navigated to the home page. So if we're navigated to the home page after following these steps, then we'll have passed. We're going to enter valid user. And then we're going to enter our valid pass one exclamation point. So I'll copy that and paste that there. And if we hit login, we are logged in. Now I'm going to jump ahead a bit just because it follows the workflow to user acceptance test 7, and we're going to look at logout. So this one states that given that we are logged into the application, which we are, when we click the logout button in the toolbar, then the user is logged out and routed to the login page. So if we're logged in here, if we hit logout, we should be routed to the login page, which we are. Cool. Now, going back, our last user acceptance test that we're going to cover is user acceptance test 6, login with invalid credentials. So if we attempt to log in with invalid credentials, we should get an error message. So given that we're on the login page, when the user enters a username and password that do not exist and click login, then the user is shown an error and not logged in. This error message is more broad, simply because we do not want a security breach by telling the potential person trying to log into the wrong system that which specific one is wrong, invalid username or password. We don't want to tell them invalid password because then they know it's the password that's wrong and not the username is correct. So just a small little security measure there. Okay. Now, we don't have time to cover in depth all of these system and unit tests, but I figure we can highlight a couple of them. We'll highlight one from each of the categories. So, starting with our backend user acceptance tests, we are looking at our BUTs. So, our backend unit tests, sorry, backend unit tests. These are written in JUnit, particularly JUnit 5, and they run automatically on our pipeline. We can look at the specification here. I do want to beef up these test execution steps. It is on my list of things to do, but it is has not been a priority quite yet. So, but I will make these better on new unit tests that are added, and then go back and make these more robust steps rather than just call register user. So we can see these are very similar to what we just ran through, except they're automated and they call methods directly rather than testing workflows. So we're calling a valid user and a valid password to the register user endpoint, and it should return a object with the username and hash password. So we're testing specific methods at a lower level. Look at this, and in this one we test with an empty value. We test with empty passwords. We test with invalid values. And we test with duplicate values. Pretty robust group of possible inputs. And so we make sure that we go through all of them so that we're testing all possible edge cases. And then we can come down to the front end user tests, unit tests. Similar to what we just saw, they're just testing the UI components, so particularly routing and error messages. So we're looking at front-end user test or FUTs, registering valid user. This is going to verify that clicking the create button returns a success pop-up. Actually, there is no success pop-up anymore. That's an old one. We want to make sure that it routes to the home page. I need to clean that up a bit. So we mock the backend call, and so we run through the logic. We render the registration page. We enter a valid username and password. We click create with user event, and then it gets routed to home. These are run with Jest and are automated through Jest. And so that we can mock the router and test that the routing works as expected. Similarly, we're testing if pop-ups appear, if error pop-ups appear. So we should be able to see the error message and test that. Finally, our systems tests are written in Cypress. Cypress was new to me. I've never written in Cypress before. I've actually never written in Jest before either. A lot of JavaScript is relatively new to me. But I have actually really liked Cypress a lot. It was a lot easier to use. Of all the new technologies I've taken on, Cypress was the easiest for me to pick up, although saying that likely means I will run into problems in the future. But that is just the way that being a software engineer goes. So we can look at some of our systems tests here. And we have one like create user. This is an end-to-end testing of create user. It runs on an actual running system in Docker. So it'll spin up Docker containers, and then Cypress will navigate to the create account page and enter in a valid username and password. And when they click create, it's actually going through the backend logic to test that it's nothing's mocked. It's all actually running. And so that allows us to do systems and integration tests through Cypress. Those tests run through pipelines, which I can show here. Okay, here we are. We're looking at a pipeline in GitHub Actions that I just ran. So this is where our automated test runs. We can see I have run this pipeline. It took about 4 minutes to run. And we can see in here all the different jobs it did, including running the backend tests, which it passed, running the front-end tests, which passed, and running the Cypress tests, which passed. It starts the application and it runs services as well. So this covers some edge case unit tests, like testing to make sure that Docker will run properly. It does that here by starting the application and then waiting for those services to start. If this check services fails, then that means that the Docker compose failed to bring them up. So it itself is doing a little bit of unit testing there. So that is pretty cool. Back to our presentation here. We looked at our testing report and user acceptance testing, and we also looked at unit and systems tests as well as an automated test example. Next, we can look at some of our test analysis. We have pretty good mix of unit and system and unit user acceptance tests added each sprint. I have definitely learned from the first sprint the order to do these in. Not that that wasn't there before, but I think that there was a desire to, once the code is starting to be written, you can start writing unit tests for that. But I had not written fully fleshed out user acceptance tests. I had acceptance criteria, but that was just about it. And so I've definitely hammered down that process of getting the user acceptance tests written and then the unit tests and then the systems tests. Coverage does need to be increased. We'll see that in a couple slides, and I'll discuss strategy for increasing that. So this kind of pace, this velocity of adding tests may need to increase a little bit. And then we can also look at the number of tests by looking at our traceability matrix, which is right here. So we can see our traceability matrix here. The date added is the date that they were added to the traceability matrix. I need to get better at adding them as they're being written and not adding them in bulk. As you can see, there's a big bulk of them that are added on the 21st of September. There's a few that are added on the 4th of October, and then a bunch of the rest are added yesterday. And this is the date that they are added to this matrix, to this Excel, not necessarily the date that they are written. It's just easier to track that way. We can also see that the date changed is today for all of them. I really went through this morning and fleshed out our the way that these looked. I ran them all and checked that they all passed, and so this will be a baseline for okay, they've all passed as of the 18th. So long as they keep passing and that none of these other columns change, it will stay the 18th, except for the user acceptance tests. These will get updated every single time they're run, which should be at the end of each sprint, just because they're manual. But I'm not going to update this date every time an automated test passes, if it's always been passing. Although if it fails and then something needs to change, then this will get updated. So it also maps to our user stories and our functional requirements, as well as the commit that contains the test if it's a automated test, as well as the code file containing that test. You can see that it's not available for the user acceptance test. So that's because these are manually run. We also have architecture elements that this may get updated as the architecture gets built out. Although we'll kind of talk about the state of the architecture in a bit. Now to look at our code coverage, as mentioned, it's a little lower than I would like it to be, particularly for the back end. I have a goal to get this up to 75%, and it's only sitting at 49% on instructions and 43 on branches. That needs to be higher. Just nothing else to it. That needs to be higher. There is strategy to get this higher. There are a lot of getters in the model that are not being tested. Those can have unit tests written for them pretty quickly, or at least relatively quickly compared to some more complex unit tests. Just testing getters shouldn't be too bad. And then our controller, I've had issues in the past with WebMVC, with mock WebMVC. And so I've been hesitant about testing the controller, but in order to get that code coverage up, I'm going to need to tackle that and handle that controller. Testing the config file is difficult. I would have to do a lot of research there. I've never tested a config file before. I'm sure it's possible, but it would probably require a lot of mocking and a lot of auto wiring beans, which can get messy with Java Spring Boot. And so I would like to avoid that. As more services and more models get added, they should be tested at a much higher percentage of code, possibly anywhere between 80 to 90% of that new code being tested. And so I'm hoping that between the controllers being tested and new code being added with a high rate of testing, that will bring that total up to 75% where we would like it to be. Front-end testing looks a lot better. You can see that the utils file is the lowest and it's sitting at 75, which is at our goal. It's only got a 50% function rate though, although again, not a lot of code in the front end right now, so that can certainly be raised, but it is not as high of a priority as the back end right now, simply because it's meeting, or at least close to meeting our requirements, and should only continue to increase from here on out. Systems test, very similar story to the front end tests. If you're looking at probably the same code that it is looking at, but that code coverage is looking very, very good, well above where I aim for it to be at the end. Looking very good. With that, we can go ahead and move on to section 3. In section 3, we will look at some wrap up and reflection on the project as a whole. So a quick project review. This is looking at both sprints as well as a lot of the preliminary work that we looked at in the first 2 weeks of the course. All planned tasks and user stories were completed for the first 2 sprints. I think that that's a testament to planning and estimation, but is also a little concerning because some role wouldn't be bad. I think that that more refined planning might help with that. I think maybe it's been a little too general, allowing tasks to close out without a super specific definition of done, especially in sprint 1. It got a lot better in sprint 2, which we'll get into later, and it'll continue to get better in sprint 3. Our documents are developing. The SRS is looking very robust. We can take a look at that here. And we can see that requirements are filled out in here with acceptance criterias, as well as functional requirements and non-functional requirements being detailed, and then a lot of constraints and assumptions and system features, and a lot of this kind of overhead work has been written out and can be edited in the future, but having this written out now is going to be a big help as this living document continues to evolve. The only empty section is the algorithmic component, which will be worked on this coming sprint. Our testing report is also developing nicely. We've looked at it a little bit, but it also has all the tests being documented, as well as the user acceptance tests are being documented as they pass. We can see that down here. We have results for our user acceptance tests at the bottom there. And so that's really good to see. Some code coverage results, and the traceability matrix is linked, but the code coverage results will come at the end of the project, and then that's just some templates for me to use when I'm building out new test specifications. Our architecture design document definitely needs work. This is the document that needs the most work. I have a few diagrams in here, particularly some diagrams regarding the deploy script. So this is a activity diagram and a sequence diagram for the deploy script. I also have the domain model and the architecture that we've looked at earlier, and a rough outline for the document, but that definitely needs to be worked on more and will be made a priority going forward. And then not listed here, but the end user manual is also coming along nice, documenting steps for running each of these user stories is very important. And so that is going to continue to happen. It is a little behind. We have the deploy system and load seed data documented thoroughly in here with screenshots, but we do need to do the account creation and the system login and logout. So I fell a little behind on that, but I will catch up on that, and as well as continue to add new steps as user stories are implemented. The source code is also stable, and the coding pace is good so far. We'll kind of look at that as we look at some charts in the next couple slides. Starting with our burnup chart. This is our burnup chart for sprint 2 in particular. So you can see that it starts low at the beginning. There was some overhead for sprint planning at the beginning of the sprint, as well as as well as some investigation needing to be done for the deploy script, learning the best language to write it in, settling on Bash, and then some overhead once the first step was to Dockerize our front end and our back end, and ran into some bugs that needed to be fixed with that as part of that task, particularly with React Router in Docker Compose. I learned that there are some changes that need to be made to the config files in order for that to work. So that's why there was a slow start with no tasks being completed until about the end of that first week. But then you can see in that second week, it quickly picks up at a pretty steady pace of closing tasks with a small plateau. In the weekend, that is mostly because documentation was being worked at the end of completing a lot of the code work. And then at the end here, we can see a steady rise to meeting our goal. That last week was really documentation heavy. A lot of the tasks in that sprint were documentation heavy. And so as they got wrapped up, they led to the culmination of this demo, which is being completed as I speak. So looking at the project review as a whole, there are many challenges that I faced throughout this project. Mainly learning to wear many different hats in a solo project has been a challenge. While a lot of what I'm doing I've done before on an individual basis, putting it all together has been a bit of a challenge. Learning what to prioritize, keeping it all organized has been a big challenge for me. The organization is key. Just learning how important it is to stay organized, keep your tasks organized, knowing that I need to write code, but I also need to write tests, and then I need to document those tests, and I need to document the architecture. I think that I am getting there, but there is still some room for growth on that organization. I'm hoping the definition of done for the user stories in Sprint 3 looks a little more manageable and covers a lot of that organization aspect for wearing the many hats. And that plays into balancing this next bullet of balancing overhead tasks like general documentation with tech debt and user story work, just balancing all of that work that needs to get done to ensure that our user stories are closing out and our requirements are being met. Also, technical difficulties in learning new tools and integrating with them. A lot of these tools are tools that I've heard of or at least maybe interacted with, but never actually started from scratch with or interacted with directly. Cypress is something that is, for example, something that many of my programs at work have used, but nothing that I have directly interfaced with. Similarly, React is fairly new to me. I'm taking on a role on my team right now where I'm doing some full stack work, and React is the language that we're using, but I am still learning a lot of the basics to go with React, and that's an existing project. This is starting one from scratch. There's also some external factors. I mentioned being asked to work overtime at work. We have our own MVP due, code cut off in about 3 weeks. Uh, and so that has been stressful. It's been an added stressor, not just from a time standpoint, but also from a mental standpoint. I've had to work very hard at work for 9 hours a day and then get home and attempt to spend another 4 or 5 hours on this project. So that certainly has been a challenge that has faced, and I would be remiss if I did not mention it here. There are improvements that can be made, as mentioned, better definitions of dones for user stories that evolve each sprint. I'm hoping that those continue to become more robust, and that this sprint, hopefully, I get it nailed down, and if not, in sprint 4. Although the goal is this sprint. Obviously, there's some risk of completing all user stories. I mentioned the overtime and the overhead work that has been more than initially expected. So there's a potential that what was planned was not realistic to what will actually get done. But hopefully that's not the case. Best case scenario, I still get it all done. Before we jump into the workload, I would like to look at the product backlog and just do a quick evaluation of what we have left, where we stand, discuss kind of where the app stands as far as meeting requirements. There are still many requirements in user stories to cover, but most of that foundation has been set. New tables and services and pages to add should be easier to set up now that the foundation of the application has been set up. And so while only 4 user stories have been covered, a lot of these build on the those 4 and the next ones. Creating trips will be just a new service and new table and new pages. Nothing revolutionary. This should follow the same format as our create account logic. Generating trips is our this user story 6. Generating trips is our major algorithmic component, so that should be a pretty hefty task, and it will be planned as such, probably with a high story point allocated to it. And then viewing trips, editing trips, deleting trips. These are all fairly straightforward, so I'm hoping that those go quicker than expected. Although there will be some prioritization done at the sprint planning for sprint 3 in a couple days. So looking at our workload here, we can see that Sprint 1 very a lot lower than Sprint 2. And ignoring the no iteration because definition of done has not been written for each of those, so tasks haven't been written. That's just user stories. And so as we can see in Sprint 1, the definition of done was just not robust enough. There were not enough tasks. They were too broad and they were pointed too low. They ended up taking longer than pointed for. Sprint 2 really got refined to a much better point, and it'll continue to be refined in Sprint 3. But I expect the user story count to remain roughly, probably somewhere in between. I'm gonna shoot for about 30 to 35 story points in Sprint 3. Now that I have 2 sprints under my belt, I have a better idea of how story points in this case translate to workload when I'm working part-time while working full-time. So that should hopefully even out. Continuing with our code frequency, kind of a similar story here. This is over the course of the entire project. We can see a big spike in the middle. This is by lines of code, by frequency of lines of code added. And so this is obviously you see a large number in the middle there because a lot of setup code was being created, a lot of setting up the Java Spring Boot app and setting up the Cypress tests and the React front end, and that's going to require a lot of overhead config files and package files and application files. It's just going to increase that number there. And then it drops off a bit too, as well, because the scripts were being written. That's just naturally less lines of code. The test automation was completed, and that is just one YAML file. It's not a whole a setup of a system of a tool that needs to be set up. It's just a single file, and you see a very few, almost none, written this week. That is because this week was very focused on documentation. So working through the software architecture and design document, the end user manual, the testing report, the software requirement specification, and then finally this demo, putting together the slides for this demo. And so that's why you see a drop off there. So with that said, that brings me to lessons learned here to close out this presentation. So biggest lessons learned, keep a steady, maintainable pace. The 40 story points tackled this sprint were probably a little high, and the 30 or the 20 in the first sprint were definitely low. So somewhere in between, keep a nice, steady, maintainable pace. I can't burn out. That's that last bullet point there. Don't burn out. Balance is key to quality and quantity. If I burn out, I'm not going to create quality work, and I will likely end up with lower quantity of work at the end as well. To be thorough in the definition of done for user stories, that'll help keep organized, keep me organized on all the taskings I need to do. So that's going to definitely start in sprint 3. And then setting a strong foundation. I want to make sure that everything that I build is robust so that whatever needs to be built on top of it can thrive. So with that, thank you for listening to my demo, and I hope that you have a nice day.